All right, now we're going to look at two-step equations. Okay, so equations that require more than one step to solve it. Two steps exactly, actually. So here's a example of what we're going to look at. So something that looks like this: ax plus b equals c. So this is mixing a couple of steps from the one step. So this is where you're multiplying something times x, but then you're also adding. Now you're not adding b to x here. That would mean it would have to be in brackets. You're adding b to ax. So our goal here is to isolate x. First thing we want to do is get rid of this b by subtracting it from both sides. Okay? You're not going to divide both sides by a first, because then you have to divide the b by a as well. And that makes it a little bit more complicated. So what we're going to do here is subtract b from both sides. And that's going to look like this. Okay? So subtracting b from both sides, and what you end up with then is just ax on that side, these cancel out, and equals b minus c on that side. Okay. Now what you want to do is to solve for x. So now you're down to a one-step equation with the division. So ax equals b minus c. Now divide both sides by a. Okay, so when you divide both sides by a, you get something that looks like this. And you now have x equals b minus c. Do that first, then divide it by a. Okay. So that's the idea, the big idea. Now you can basically see the process for something like a more general statement: ax plus or minus b equals c. In this case, first you remove the plus or minus b. Okay? The first thing you want to do is remove the plus or minus b. And you're going to do that by adding or subtracting from both sides. Okay? Then divide by a to solve for x. The next one is, what if you have something that looks like this? Instead of ax, it's x over a. Still do the same thing, remove the plus or minus b by adding or subtracting. But then you multiply. Instead of dividing, you're going to multiply both sides by a to solve for it. Now if you have something like this, ax over b equals c. This can be done in one step. The one step is to multiply both sides by b over a. But if you need to do two steps, then you multiply by should be multiplied by b first, and then divide by a. Okay, so it should be multiplied by b, and then divide by a. And it doesn't matter which order. You can divide by a first, and then multiply by b, or the other way around. Okay, and then you might have something that looks like this: x plus or minus b all divided by a. Instead of just the one term, it's the whole side. In that case, instead of adding or subtracting b first, well, it's not just b on this side, it's b divided by a. So what you want to do in this case is actually multiply both sides by a to get rid of it. So multiply both sides by a, then remove the plus or minus b by adding or subtracting from both sides. Okay? And that would be the same if you had something like, let's say, a times x plus or minus b equals c. In this case, you could use the distributive law and multiply that in, or you could divide both sides by a, and then you'd have x plus or minus b equals c over a. Okay, and then you would get rid of the plus or minus b by adding or subtracting. Okay, so let's take a look at some examples here. Example 1, we've got, in this case we had 3x over 5 equals negative 12. So we're going to multiply both sides by 5. Okay, that's first to get rid of that 5. And then you get 3x equals negative 60. Now you want to get rid of the 3, so you divide both sides by 3. And you get x equals negative 20. Do a check. Okay, I'm not doing a check with all of them, but you do a check for this one. Sub in the negative 20 and evaluate it. You get negative 12, which is what was on the left side to begin with. Okay. Example 2. 3x plus 2 equals 11. Subtract 2 from both sides to get rid of the 2. Then divide by 3 because you just have 3x equals 9. Divide by 3 on both sides to get rid of that 3, and you get x equals 3. And there's the check for that. Okay. Another example here. 5y minus 9 equals 6. Okay, so the unknown could be anything, doesn't have to be x. So 5y minus 9, so you're going to add 9 to both sides. Okay, get rid of the 9, the negative 9. Then you get 5y equals 15. Now to get rid of the 5, you're going to divide both sides by 5. And you get y equals 3. Okay, I've been showing a check for that. Okay, next one. Eight minus x equals 19. So just because the x is here and not here doesn't mean we don't have to isolate it. It's still isolated. Okay, so we're going to subtract 8 from both sides. This is one way of doing this. I could have also added x to both sides. Then I would have had a positive x over here. However, we can do it this way. So subtract 8 from both sides. Then you end up with negative x equals 11. We don't want to solve for negative x. We want to solve for x. So that's the same as saying negative 1x. You want to get rid of the negative 1? Divide both sides by negative 1. And then you've got x equals negative 11. Okay, so that's the trick for that one. And example 5 here. So z over 3 minus 6 equals 5. Add 6 to both sides. Okay, then you're left with z over 3 equals 11. You want to get rid of the 3, multiply by 3 on both sides, and you get z equal to 33. Okay, so that's that one. And this one, a little more complicated. Okay, it's like our last case. So you got y plus 7 divided by negative 2 equals negative 4. So in this case, you want to get rid of the divided by negative 2 first. Okay, because the whole side divided by negative 2. So you're going to multiply both sides by negative 2. Then you have a nice one-step equation of y plus 7 equals 8. Subtract 7 from both sides, and you get y equals 1. Okay, and there's a check for that one.